In this video, we will learn how to balance a redox reaction by oxidation number in basic medium. Now, the first step is always you have to find out the oxidation number. So, let the oxidation number of manganese, assume it to be X. Now, there are 4 oxygen atom and an oxygen atom is assigned an oxidation number of -2. So, 4 into -2, that is -8. So, X -8 and the charge over it is -1. So, X is equal to -1 plus 8. This is equal to plus 7. So, the oxidation number on Mn on this side is plus 7. Let's come to Br. Br minus is a charged species. Its oxidation number will be equal to its charge, that is -1. Let's come to MnO2. Let us X, assume the oxidation number of Mn be X. Now this is you can see here two oxygen atoms, so 2 into -2 equal to 0. So X minus 4 equal to 0. So X is equal to plus 4. So the oxidation number on this Mn is plus 4. Let's come to this bromine. Let us assume to be X. So X plus 2 into -3 is equal to -1, that is the charge. So X minus 6 equal to -1. X is equal to -1 plus 6. So X is equal to plus 5. So the oxidation number on this bromine is plus 5. So we are done with the first step. Let's rub it. Now, so we see that it is manganese which is undergoing change in oxidation number from plus 7 to plus 4. So that is, it is decreasing. So this MnO4 minus is undergoing reduction because there is a decrease in oxidation number, and this Br minus, the oxidation number of Br increases from -1 to plus 5. Increase in oxidation means it's undergoing oxidation. So this is undergoing oxidation. Now we have to see the species which are undergoing oxidation and reduction, the number of their atoms, are they equal or not? If not, we have to equate them. So 1 Mn, it is balanced. 1 Br, it is also balanced. So this step is over. Next, what we have to do, we have to find out the decrease or increase in oxidation number. See here, this Mn, in Mn there is decrease in oxidation number by 7 minus 4, that is by 3 units. And here Br, there is increase in oxidation number by -1 becomes plus 5, that is 0, 1, 2, 3, 4, 5, 6 units. So 3 units here, 6 units here. Now we have to balance this change in oxidation number by multiplying them with the required number, So how can we make 3 equal to 6? We can make it by multiplying it with 2, and obviously 6, if we multiply with 1, will become 6. So in this way we can balance the change in oxidation number. So when we are multiplying this species 3 with this 2, that means we have to put 2 in front of this Mn. O4 minus on this side. In case of Br, we have to multiply with 1, so we are not writing 1 here, and 2 here, plus BrO3 minus. So this step is done. Next, we have to balance the oxygen atoms by adding required number of water molecules to the side deficient on it. We see that on this side there are 4 into 2, 8 oxygen atoms, but on this side 2 2s are 4 plus 3, 7 oxygen atoms. That is, on this side there is deficiency of 1 oxygen atom. How to balance it? By adding 1 water molecule. So we will add just 1 water molecule. Now Next step, because this equation is in basic medium, so we have to add OH minus, please remember. So let's write this equation once more. Mn 2MnO4 minus plus Br minus, let's put some space, 2MnO2 plus BrO3 minus plus water. So you see there is one water molecules. Now we have to balance this water molecules by seeing how many hydrogen atoms are there. There are 2 hydrogen atoms, so we have to add 2 OH minus. Now there is the second next rule is that you have to add equivalent number of water as the number of OH minus on the opposite side. So because there are 2 OH minus, so on this side we have to add 2 H2O. Okay, so finally we see that this equation there are 2 H2O and 1 H2O, so this water will come to this side, and so 2 water minus 1 water will become 1 water. So 2 MnO4 minus plus Br minus 2 water minus 1 water, that is 1 water, giving us 2 MnO2 plus BrO3 minus plus 2 OH minus. So this is the balanced redox reaction in basic medium, but the job is still not done. We have to check whether we have balanced it correctly or not. So let's count the number of atoms on both sides. Mn2 here also Mn2, so it is balanced. Oxygen 4 2s 8 plus 1 9, oxygen 2 2s are 4, 4 plus 3 7 plus 2 9, balanced. Then bromine 1, bromine 1, hydrogen 2, hydrogen 2. So the number of atoms of each element on both sides of the equation are equal, but we have to check the charge also. Charge on this side, 2 into minus 1 minus 2, and this minus 1, so minus 2 minus 1 minus 3, and let's see the charge is same or not on this side. See minus 1 here, and 2 into minus 1 minus, so minus 2, so minus 1 minus 2 minus 3, so the charge is also balanced. That means we have balanced this redox reaction accurately and correctly. So let's balance one more redox reaction by oxidation number method in basic medium. The equation is Pb2 plus IO3 minus gives us PbO2 plus I2. So the first step, as usual, we have to calculate the oxidation number. Pb2 plus, you can see it is in charged form, so the oxidation number will be equal to its charge, that is plus 2. IO3 minus 3 oxygen atoms, so 3 into minus 2 minus 6, so x minus 6 equal to minus 1, so that means x is equal to minus 1 plus 6, so that is plus 5, here plus 5. Now you should be in a position to find out the oxidation number mentally without calculation. PbO2, 2 oxygen atoms, 1 oxygen minus 2, so 2 into 2 minus 4, so this will be plus 4, and this is a free state, so it will be 0. Now let's check out the elements which are undergoing change in oxidation number. Are they balanced on both sides or not? If they are not, we have to balance them. Pb is undergoing change in oxidation number. See, from plus 2 it has become plus 4, so there is increase in oxidation number, means it is undergoing oxidation number. And iodine, the oxidation number decreases from plus 5 to 0, so it is undergoing reduction. So because Pb is undergoing oxidation, so we have to check whether its number of atoms are same on both sides. One atom of Pb, here also it's balanced. Check iodine, 1 iodine, but here 2 iodines, so we have to make it 2 here. The next step is to find out the change in oxidation number, that is decrease and increase in oxidation number. So oxidation number increases from +2 to +4. So increase in oxidation number by 2 units. Let's come to iodine. See, iodine's oxidation number changes from +5 to 0. That means what? 4, 3, 2, 1, 0. 5 units. So decrease in oxidation number by 5 units. But we are seeing that there are two iodines, so we have to multiply this 5 by 2, so it will become 10. So we have reached here. We have come to the next step, that is we have to balance this change in oxidation number. This is 2 unit, but now this is 10 unit. How can we make 2 10? Simply we have to multiply this with 5. That means we have to multiply Pb on both sides by 5. So 5 Pb2 plus 2 IO3 minus gives us PbO2 plus I2. So this step is done. Now it's the time to balance the number of oxygen atom by adding water molecules to the side deficient in it. So you see here 2 into 3, 6 oxygen atoms on the left hand side, but on the right hand side we are seeing that, we have to write 5 here also. So on the right hand side we are seeing 5 2s are 10 oxygen atoms. But here 6, 2 3s are 6, but here 5 2s are 10. That means this side is deficient by how many? 6 and 10, 4. So we will write 4 water molecules on this side. Let me write. Always keep some space so that you can write the equation in one line. Okay, so 3 2s are 6 plus 4 10, 5 2s are 10. Now it's the time to balance hydrogen atom. There are 8 hydrogen atom. How to balance this? We have to balance this by adding OH minus ion, because I have told you in case of basic medium we have to add OH minus ions. How many hydrogen? There are 4 2s are 8 hydrogen. So we have to write 8 OH minus. So 5 Pb2 plus 2 IO3 minus plus 4 H2O plus 8 OH minus. 4 2s are 8 hydrogen, that's why 8 OH minus 5 PbO2 plus I2. And here one more thing, the number of OH minus you add, same number of water molecules you have to write on the opposite side. That is because we have added 8 OH minus, so we will add 8 H2O. Now we see that in this equation there are 4 water on this side and 8 water molecules on the right hand side. So this will go to this side, and finally we will have this equation 5 Pb2 plus 2 IO3 minus plus 8 OH minus gives us 5 PbO2 plus I2. 8 water minus 4 water, so 4 water. So this is the final equation, but still we are not done with. We have to check whether the number of atoms of each elements are equal on both sides or not, and also the charge. See, 1 lead, Pb is 1, 5 into 1, that is 5 Pb here also 5 Pb, so Pb are balanced. Next come to iodine, 2 iodine, there 2 iodine balanced. Oxygen, let's count oxygen, 2 3 is 6 plus 8, 6 plus 8 14, 5 2 is 10 plus 4, 14 oxygen balanced. Hydrogen, 8 hydrogen, 4 2 is 8 hydrogen balanced. Finally the charge, if the charge is also balanced, then we'll be in the stage of accuracy. So charge is equal to 5 2 is 10, that is plus 10 plus 2 into minus 1 minus 2 and 8 into minus 1 minus 8. So this is plus 10 minus 10, so this is charge on this side is 0, and you see here there is no charge, so charge on this side is also equal to 0. So that means we have balanced this equation correctly. So this is the way you will balance redox reaction by oxidation number method in a basic medium. Please go through this video once more so that your understanding is accurate and you are in a position to solve any question on this method. That's all.